Welcome back. I'm and today we're unlocking the secrets behind the metal objects you use every day. From your morning spoon to your car, there's a world of heat, precision, and power behind their creation. I found 6 of the most jaw-dropping manufacturing and metalworking processes. Some ancient, some futuristic. Each one will change how you see the everyday things around you. So, let's dive in. No safety goggles required, but you might want to brace yourself for some serious engineering magic. Let's get started. First up, CNC machining, where computers control cutting tools with mind-blowing accuracy. Imagine a sculptor, but instead of a chisel, it's a spinning carbide bit, and instead of marble, it's solid metal. The operator loads a digital blueprint, locks in a metal block, and, with a button press, the machine takes over. Coolant floods in, the spindle spins at thousands of RPMs, and the cutting tool carves away metal like it's butter. Chips fly, and the machine moves in 3 axes, following the code with microscopic precision. Tolerances thinner than a human hair. This is how your phone, car engine, and airplane parts are made. Complex shapes, perfect every time. The machine automatically swaps tools, roughing out shapes, then finishing with a mirror-smooth pass. It's a dance of software and hardware, every move calculated, every cut flawless. What would take days by hand is done in minutes, with every part identical to the last. The final pass reveals a gleaming, perfectly formed component. CNC machines are the hidden heroes of modern manufacturing. Even the machines themselves are made with CNC parts, a cycle of precision. It's mesmerizing to watch, and it's the backbone of our tech-driven world. From raw block to finished part, it's pure engineering magic. The process is fast, consistent, and endlessly repeatable. That's why your gadgets work so flawlessly. The next time you hold a metal object, remember? It started as a dumb block, transformed by code and steel. CNC machining is the silent force shaping our future. It's the ultimate blend of art and automation. And honestly, I could watch these machines work all day. Let's journey into the world of the samurai swordsmith. Forging a katana is a centuries-old ritual, blending art and skill. It begins with Tamahagan steel, heated and hammered into a single block. The smith folds and hammers the steel, creating thousands of layers for strength and flexibility. The blade is coated with clay, thick on the spine, thin on the edge, for differential hardening. After heating, it's quenched in water. The edge becomes razor-sharp. The spine stays tough. Weeks of polishing reveal the hamon and hata, unique patterns born from the process. Every katana is a masterpiece, forged by fire, skill, and tradition. It's a weapon, a work of art, and a symbol of mastery. That's the art of the samurai sword. Now, let's scale up to the modern car factory, a place where precision meets pure scale. It all starts with the body in white, raw metal panels stamped into shape, robotic arms swing into action, welding panels together with a flurry of sparks and sub-millimeter accuracy. This is robotic ballet, dozens of machines moving in perfect harmony, building a car's skeleton in minutes. The painted body glides through chemical baths, then robots spray on color with electrostatic precision. Paint is drawn to metal for a flawless finish. In final assembly, humans and robots work side by side. The marriage moment. The painted body is lowered onto the chassis, uniting engine, suspension, and frame. Teams install dashboards, seats, and glass, while robots handle adhesives and bolts. Every part arrives just in time, thanks to a logistical masterpiece. Doors are reattached, wheels bolted on, headlights tested. Every step is checked and double-checked for quality. At the end, fluids go in, the key turns, and the engine roars to life. In under 20 hours, a roll of steel becomes a finished car. The scale and speed are staggering. It's a symphony of automation and human skill. One missing bolt could halt the whole line. Precision is everything. The car drives off, ready for the world. This is manufacturing on a monumental scale. Robots bring power and consistency. Humans bring adaptability and finesse. Together, they create something extraordinary. The car assembly line, where engineering dreams become reality, and it all happens faster than you'd ever believe. Time for something primal, the raw power of the hydraulic press. Using Pascal's principle, a small force becomes hundreds of tons of crushing power. Watch as a steel-bearing ball, tough enough for machinery, is flattened effortlessly. The press applies relentless pressure, no drama, just unstoppable force. Next, a stack of forged steel wrenches, tools built to last, are slowly bent, twisted, and compacted into a single, mangled lump. It's a slow-motion display of total domination. Now, a cast iron engine block, strong but brittle, faces the press. Resistance, then a sudden, explosive shatter. Chunks fly, safety shields rattle. The difference between ductile steel and brittle iron is clear. One bends, the other breaks. Hydraulic presses aren't just for crushing. They forge, stamp, and shape metal in countless industries. They're the muscle behind everything from car parts to kitchen sinks. But let's be honest. Watching them crush things is just plain satisfying. It's the ultimate what-if machine. What if we squashed a bowling ball or a stack of hard drives? The results are always spectacular. Hydraulic presses show us the limits of material strength and the power of pure force. They're essential tools, but also irresistible to watch. Every crush is a lesson in physics and engineering. The press is silent, steady, and absolutely unstoppable. It's mechanical power, distilled. And it never gets old. The next time you see a metal object, remember, it might have faced the press. Crushing, forging, shaping. Hydraulic presses do it all. It's manufacturing muscle at its finest. And it's always a thrill to watch. Now, let's jump to the future, metal 3D printing, or direct metal laser sintering. Instead of cutting or forging, this process builds objects from metal powder, layer by microscopic layer. It starts with a 3D computer model, sliced into hundreds of ultra-thin layers. A roller spreads a fine layer of powder, a laser fuses it into solid metal, tracing each slice. The platform lowers, another layer of powder is added, and the laser repeats, over and over until a complex part emerges. You can create shapes impossible with any other method. Hollow channels, intricate lattices, internal structures. The loose powder supports the build, then is brushed away to reveal the finished part. Post-processing, heat treatment, support removal polishing, completes the transformation. This technology is revolutionizing aerospace, medicine, and beyond. Jet engine parts are lighter and stronger. Custom implants fit perfectly. It's a shift from subtractive to additive manufacturing. The possibilities are endless. 3D printing lets us design without limits. It's not science fiction. It's happening now. From powder and light, we create the future. The process is mesmerizing. The results, game-changing. We're only scratching the surface of what's possible. Metal 3D printing is the next frontier, and it's just getting started. Finally, my favorite, sand casting, one of the oldest and most magical metalworking methods. It starts with a pattern, often wood or plastic, placed in a two-part box called a flask. Fine, sticky sand is packed tightly around the pattern, capturing every detail. The flask is split, the pattern removed, leaving a perfect cavity in the sand. Meanwhile, scrap aluminum is melted in a furnace until it's a shimmering pool of liquid metal. The molten aluminum is poured into the sand mold, filling every nook and cranny. As it cools, the metal solidifies, taking the shape of the original pattern. The mold is broken open, revealing a brand new aluminum object, still hot, still glowing. Extra metal is trimmed, and the piece is cleaned and polished. From scrap and sand, a detailed, useful tool is born. It's a process thousands of years old, but still feels like magic. Sand casting transforms the ordinary into the extraordinary. It's elemental, hands-on, and endlessly satisfying. The simplicity is deceptive. The results, stunning. Every cast object is a small miracle of heat and ingenuity. Watching the reveal is pure drama. From trash to treasure, sand casting is manufacturing alchemy. It's proof that sometimes, the oldest methods are still the most beautiful. Metal, sand, fire, and skill. Nothing more, nothing less. That's the magic of sand casting. And that's a wrap. From CNC precision to sand casting magic, manufacturing is a blend of science, art, and raw power. I hope you see everyday objects in a new light. Which process blew your mind? Let me know in the comments. Hit like, subscribe, and tell me what how it's made mysteries you want to see next. Thanks for watching. See you in the next one.